What if the closest living relative of the dodo was still out there hiding in Samoa's forests and we might lose it for the same reasons? Today we follow the Manumea, the tooth-billed pigeon, with a serrated beak built to crack the Maota tree's toughest fruits. It's critically endangered, with estimates suggesting fewer than 200 individuals remain in the wild, and it's being accidentally shot when hunters aim for another pigeon. Stay with us as we trace its evolutionary lineage, the converging threats, repeating history, and the technology that could tip the balance from ghost story to survival, starting with why this dodo cousin is still walking today. So let's tackle what keeps this story from ending the same way, a dodo that did not die. On the evolutionary tree, the Manumea sits in a narrow branch with deep roots. It is genetically close to the dodo, sharing ancestry within the same evolutionary clade shaped by Pacific islands rather than continents. You're looking at an outlier that kept traits from a vanished world, yet survived in Samoa long enough to be known, named, and now debated over how to keep it alive. That history makes it more than a rare bird. It's a survivor of a family that has largely gone silent. Here's the puzzle. Both birds evolved on islands with no native mammalian predators. Both met people bringing guns, dogs, and rats, and both faced forests that could be felled or burned. Yet one vanished within a human lifetime, while the other still slips through valleys and ridges. The shared vulnerabilities are clear. The timelines are not. Mauritius met sustained colonial pressure early with permanent settlements, intensive hunting, and rapid conversion of lowland forests into sugar fields and ports. In that cascade, a big ground foraging bird with little fear and no dispersal buffer had nowhere to go. Samoa saw outsiders, but large-scale land conversion rolled out later and unevenly, and rugged interiors kept pockets of native forest beyond easy access. Customary land tenure, most land controlled by villages, also created different conservation dynamics than plantation systems, shaping how pressures spread and how communities could respond. Modern assessments describe a smaller range than historical accounts and a population that trends downward over decades rather than collapsing at once. That slower slope reflects how island isolation can buffer shocks. Ridges create refuges. Fruiting cycles vary between valleys, and access limits how fast threats fill every niche. But isolation is a delay, not a shield. Classic island biogeography tells you that small ranges and small populations raise extinction risk once disturbance outpaces recovery, and the risk compounds because rescue from outside populations does not exist. There's also what makes this bird uniquely costly to lose. Its branch on the pigeon family tree is long and distinctive. Remove it and you prune an entire connection to the dodo's lineage, taking with it behaviors and anatomy that do not appear elsewhere. Conservationists rank it among the most evolutionarily distinct and globally endangered birds, which means one loss erases a disproportionate amount of evolutionary history. So why did it persist when its cousin did not? Samoa retained interior forest blocks that buffered the first waves of hunting. Early human pressures were lower in intensity, and reach and community control of land slowed sweeping conversion. Those advantages are thinning as forests shrink, and on the island, pressures align with a familiar pattern. One feature ties that history to day, survival, a bill built for hard native fruits that few other birds can exploit, a specialization that opens food and risks. Which brings us to the hardware that makes that strategy possible, the serrated beak and the Maota. Start with the bill. It's thick, curved, and notched along the edges, with tooth-like points on the lower mandible that behave more like a can opener than a pecker. That design is not for show. It grips saws and leather, open hard-skinned fruits that most birds drop or ignore. In Samoa, that means the fruits of Disoxylum maota, whose tough outer layers require force and precision. The Manumea's bill pries apart the aril and exposes the seed without shattering it, a delicate balance of strength and control that lets the bird feed where generalists fail. Lean too far into one food, though, and you inherit its boom-bust calendar. When Maota crops are strong, the bill pays off. When fruiting dips or trees vanish from a valley, specialization turns into scarcity. That risk becomes real when forests thin, because the bird's main tool is only as good as the trees that produce the workpiece. And Maota are primarily lowland trees, typically below about 2,625 feet, which helps explain why detections concentrate in those belts, even if the bird can wander higher when food and cover align. Watch how it feeds, and you see the bill's full job description. The bird moves between the ground and low to mid-canopy, tracking fruit falls and inspecting clusters. It braces a fruit against a perch, or the forest floor works the beak along a seam and strips the tough tissues to reach the edible parts. Seeds pass through or are dropped intact, spaced away from the parent tree, which matters when seedlings compete for light and soil. The process is slow, and the bird stays focused, which helps with careful handling, but extends the time spent in one spot. Anatomical descriptions highlight those serrations and the hooked profile as adaptations for Maota processing, and field workers have linked sightings and feeding signs with Disoxylum availability. Habitat models run in 2024 point in the same direction. Forest cover and Maota presence predict where the Manumea turns up. Elevation once thought to define a narrow band shows a weaker signal in several models, hinting that the bird ranges higher than older records suggested when food and cover align. That feeding niche has ripple effects. By moving seeds across distances and into gaps, a single species can tilt how plant communities assemble after storms or logging. When you remove the disperser, heavy seeds often fail to travel far and recruitment stalls near parent trees. The 2024 distribution work reinforces that connection. Where continuous forest and Maota persist, the maps light up. Where they do not, detections fade with a caution that automated listening can misclassify calls and inflate hope if not carefully checked by trained ears. Here's the trade-off built into the hardware. The beak grants access to tough fruits, but the workflow is slow. Handling time on the ground and repeat visits to fruiting trees create patterns that others can exploit. Predictable sites bring predictable risks, and you do not have to target the Manumea directly for those risks to take a toll. How do you drive a species to the edge without ever targeting it? You do it by aiming at something else. In Samoa's forests, Bycatch is not a net or a long line. It's a shotgun blast meant for the lupe that lands on the Manumea. In terrestrial hunting, Bycatch means a mistaken ID in fast low light shots when a large pigeon slips between branches, and the difference in bill or posture is invisible until it's too late. The lupe carries cultural weight in food hospitality and status. That demand pulls a chain that starts with shells and ends on a plate. Vendors sell ammunition, hunters organize weekend trips, middlemen move dressed birds, events and high-status gatherings showcase the meat. In a country with a tiny Manumea population, even a handful of errors per season compounds across valleys and years. Small numbers stack quickly when the denominator is a few remaining breeding pairs. Survey work backs up how this plays out. Sterneman and colleagues reported more than 22,000 pigeon meat units consumed annually, with the top 40% of consumers driving roughly 80% of demand. About a third of surveyed hunters said they had shot a Manumea while targeting lupe. Those are not deliberate kills. They are the fog of the forest outcomes of split-second choices. You rarely see the damage. The bird is shy, densities are low, and carcasses do not enter official reporting. Missed detections mask losses, so trends look flatter than reality. In response, the Save the Manumea campaign tests levers that communities can actually use, limiting ammunition, village-level hunting bans, and public awareness grounded in social change theory. Pilot villages like Faleasela and Wafato report stronger enforcement, pest control, and native tree planting as norms shift. Can social pressure and targeted rules move faster than decline? Where villages cut shell sales and enforce bans, Bycatch drops quickly relief without waiting for new tech. But hunting pressure is not acting alone. Predators and storms squeeze the same forest edges where the Manumea nests and feeds. So the rest of the pressure comes from the forest itself, predators, storms, and a vanishing forest.
What happens to a ground nesting pigeon when the forest floor becomes a hunting ground?
Rats get there first. Black rats climb, sniff, and take eggs and chicks before dawn, and they do not stop at one nest. Cats prowl the same trails and edges, hunting by sound and movement, and a slow ground-oriented bird makes an easy target at night. Add pigs turning over soil and seedlings, and you get nests, exposed paths, widened and scent everywhere. A species that likely nests near the ground faces a predator suite that did not exist in Samoa's original forests, and every clutch becomes a gamble with long odds. Now mix in storms. Cyclones like Evan in 2012 knocked out canopies over large areas, broke fruiting branches, and dumped unripe crops in a single day. After the wind light pours in, the understory thins, and the new openness favors predators that navigate by sight. Food dips right when adults need energy to breed, and chicks need consistent meals. Storm debris also creates edges where none existed, and edges draw in rats and cats that move along logs and open runs. After major cyclones, invasive plants often take hold in the gaps, changing how the forest regenerates and crowding out the native trees that feed specialist birds. You can see how the calendar turns against juveniles. In good years, Disoxylum and other fruiting trees carry peaks that let pairs feed chicks steadily. When repeated storms and clearing remove those peaks, parents extend foraging trips and return less often, and chicks fledge at lower weights if they fledge at all. Layer deforestation on top of that, and fruiting becomes patchy, so the best valleys carry too many birds and not enough food, and the weak fall behind first. National reporting points to ongoing forest loss and climate pressure that keep tightening this vice. Lowland native rainforest has been cut back to small remnants on both main islands, and the State of the Environment 2023 records stronger storms and altered rainfall that stress trees and favour invasive plants after disturbance. Field notes add the local view rat signs at nests cats working along newly opened tracks, and pigs rooting through the same flats where birds feed. Each disturbance effectively lowers the ceiling on how many young a pair can produce and raise in a season. As the habitat breaks into pieces, Manumea retreats into smaller refuges with good cover and fruit. That helps in the short term, but it also concentrates them in places that are easy to patrol, easy to trap, and easy to hunt. Acoustic monitoring and recent models highlight a few higher suitability corridors, including the rugged interior of Central Upolu, which now carry more of the burden for the whole population. Fewer safe places means more predictable movements, and predictability is what predators exploit. Can technology and hands-on control keep pace with that stack of threats? The answer depends on speed and focus. Rats and cats are the solvable layer. When teams run bait stations and traps on a grid, keep them serviced, and pair that work with planting native trees like Disoxylum to restore fruit supply, breeding, chances stabilize, and fledglings get a window to survive. The catch is finding the birds in time and in the right places, which starts with proof of presence that you can act on. So the next move is to switch senses and let the forest talk. Listening for ghosts tech that buys time. How do you protect a bird you almost never see? You start by listening. Automated acoustic recorders left on trees across valleys and ridges run all night and all season, turning air into data. One device captures thousands of minutes. A countrywide array turns that into millions. Instead of waiting for a rare glimpse, you map where calls occur, how often they repeat, and which habitats they use at different times of year. That scale matters when a species lives at low density and moves quietly between forest blocks that are hard to reach on foot. The challenge is that Manumea calls are uncommon and not always obvious. Wind insects, lupe, and other forest sounds overlap in frequency, and an algorithm can mistake one for another. Confusion between Pacific pigeon and Manumea calls is a known problem. A few wrong labels send teams into the wrong valleys and waste scarce batteries, bait, and time. False positives are not just errors on a spreadsheet. They move people and money away from places that actually hold birds. Field teams cut through that noise by stacking tools. They train models on curated clips, then add a second pass where trained listeners review candidate detections by ear. They carry reference libraries built from known calls and tag background species to reduce confusion. Crucially, they do not work blind. Hunters, guides, and village leaders point to ridges with fruiting and Maota, seasonal streams, and old paths where pigeons cross at dawn. The mix of local knowledge and cautious vetting turns thousands of weak hints into a smaller set of credible points on a map. In practice, grids of dozens of recorders, 72 units in one deployment can cover multiple valleys and return a clean shortlist of likely sites. This effort sits inside Samoa's recovery plan for 2029 with partners that cover government, science, and zoos. MNRE, the Samoa Conservation Society, ANU Auckland Zoo, and SPREP among them, each handling a piece of the pipeline from deployment to analysis to field action. The cycle is straightforward but powerful. Assess by listening plan, by drawing hotspot maps, and act with targeted work predator control grids under likely territories, temporary hunting restrictions near active sites, and planting of native trees to rebuild fruit supply. Because the recorders keep running, new results feed back into the plan and the loop tightens rather than drifting. Recent confirmed detections near Wafato show what that loop looks like on the ground. Once calls passed, manual vetting teams shifted traps into adjacent gullies, set up bait lines to intercept rats along ridges, and met with village councils to agree on no hunt windows around the mapped core. Outreach followed the data, not a generic schedule, so effort matched evidence. The dodo had no time for this kind of feedback loop. Ocean crossings, settlement, and exploitation outran any intervention. The Manumea might. When an acoustic hotspot brightens, crews do not wait. They lay rat stations at 164-foot spacing, stagger checks to match breeding windows, add Maota seedlings along nearby edges, and support village bands where calls cluster. Quiet recordings become specific maps, and maps become immediate steps that keep a rare lineage present and a working seed engine turning in Samoa's forests. That approach points to what matters most, now a clear path to act, not guess. Saving the Manumea keeps a rare lineage alive and keeps Samoa's forest engine running. Lose it, and you lose a seed mover that spreads heavy, hard-case fruits into the next generation of canopy. You can help. Support groups working with villages on hunting bans, predator control, and native tree planting. Reduce demand for wild-caught pigeons by choosing alternatives and challenging prestige buying. Share verified sightings with authorities so teams can act where evidence points, not guesses. Extinction repeats when the same pressures align. This time calls still echo in a few valleys, and action that can keep them echoing longer.